Hey guys, so I'm making this section 4.2 exercises video for you guys so that you can, as you're going through the exercises online, if you get confused on a question where you're like, I totally don't understand what this is asking, uh, instead of being confused on how to do it. I know some of these questions are formatted kind of odd. So this video is specifically for you guys to be able to understand what the question is asking. I'll do some of them with you all the way. Some of them I'll just kind of give you hints. But I'm not going to do every single one of them. And I've color coded them, as you can see. Like one is red, this one's yellow, this is orange, and so are 5, 7. So because they're all color coded the same, that means they're all done the same way. So I might just explain one or two of those orange ones, but so because they're all done the same way. So starting with exercise number 1, we've actually already seen this question. It was the first question on exercise 4.1 as well. The only difference for this one is that we now are not just having the variables, so something like x is less than 5. We now are doing something to those variables. We have an operation with it, either addition or subtraction for 4.2. So here we have the two inequalities, c plus 3 is greater than 5, and c is greater than 5 minus 3. And what we're being asked is, are these inequalities the same? And so if you think back to the notes, or if you look at the notes that you're currently doing right now for 4.2, that's all about solving the inequalities and also using what we call the addition property of inequality, or the subtraction property of inequality, meaning that we can add or subtract something to both sides of an inequality and still keep it the same. So just if you are a little lost on what I'm talking about, here's an example. If we had something like x plus 3 is greater than 7. If we were to subtract 3 from both sides, then technically speaking, because we subtracted 3 from both sides, this is still the same inequality. It still has the same truth. X is still going to be less than 4. I'm sorry, greater than 4. And so what this is asking you here for this first question is c plus 3 greater than 5 the same thing as c is greater than 5 minus 3? Well, you can do this. You can test this one of two ways. You can plug in any number for c and see if you get the same response every time, or you can use that knowledge that you just learned on subtracting or adding to both sides and seeing if if that's what's been done here for this. So we have c plus 3 is greater than 5. If we were to get the c by itself like we have it over here and turn it, we would want to subtract the 3 from this left side and the 3 from the right side, and that would leave us on this left side with just c. And then on the left side, instead of solving that out, 5 minus 3 being 2, we could leave it as 5 minus 3, and you'll see that you actually do get the same inequality here as this. So yes, these are the same inequality. And then because of which property, what did we do? Did we add or subtract? And so that will help you solve number 1. Exercise number 2, which inequality does not belong with the other 3? So looking at these 3, and then we've got some questions too. Explain your reasoning. The inequality does not belong with the other 3 because to solve this inequality, you use the blank property of inequality. To solve the other 3, you use the blank property of inequality. So it's not asking us about which ones have the same symbol or which ones have the same value, because they all have this. What it's really asking us is, how are you solving them? What property of inequalities are you using to solve? Well, if I wanted to solve this first inequality, what I would want to do here is I would want to subtract the 7 and 4/10 from both sides, because that would leave me with just the w is greater than 3 over 4 minus 7 over 4. So in that one, I use what would be the subtraction property of inequality. So I'm just going to call that subtraction POI. Number 2, w minus 3.4 is greater than negative 7.4. To solve this, I would add 3 and 4/10 to both sides in order to get to w by itself. And so in that one, I would be using the addition property of inequality. Let's move on to number 3, w plus 7.7 over 4. I would want to subtract 7/4 from both sides to get that w by itself. That would be the subtraction property of inequalities. Number 4, w plus 7/4 is greater than greater than 3/4. To solve for w, I would want to subtract 7/4 from both sides, which is a subtraction property of inequalities. So as you can see now, the number 1, 3, and 4 all are using the subtraction property of inequality, while number 2, the different one, is using the addition property of inequality. Okay, for exercises 3, 5, 7, 9, 10, 11, 12, these all have the same thing. 13, 14, you're going to be doing this for a while. 16, so all the way up to 16, the things that you're going to be doing for this, where is number 5? What you'll be doing for these are, you're going to be solving the inequality. And just a reminder, this means that you're going to be either adding or subtracting something from both sides to get the variable by itself. And then you're going to be, looks like they want you to graph the solution as well. So I've got 3 is less than or equal to 7 plus g. If I wanted to get that g by itself, I need to get rid of I only have 2 options, either the 3 or the 7. But because the 7 is the one that's hanging out with the g, I want to get rid of that. Well, if I have 7, I can get rid of 7 by subtracting 7 from both sides. And subtracting 7 from both sides will leave me on my left side with 3 minus 7 is negative 4. Symbol always stays the same in addition or subtraction. And then positive 7 and minus 7 are going to cancel out to give you 0. And so the only thing you'll have left is g. And so now my solution that I would plug in is the whole thing, negative 4, less than or equal to g. Make sure you plug in the whole inequality. And then you're going to graph that solution. And so if you understood 4.1, graphing the solution should be pretty straightforward. We're going to find negative 4, use a closed circle because it is equal to or less or greater than. So g is equal to negative 4 or at all the values greater than negative 4. Make sure that you are reading the inequality properly for the variable. Even though that's a less than or equal to sign, if you read it from left to right, it's negative 4 is less than or equal to g. But we want to graph the solution for g. So if you read it backwards, if you read it from right to left, it's g is greater than or equal to negative 4. So the direction that you read it does matter. It's still the same inequality, but it'll help you graph it if you read it properly. Okay, so that's what you're going to be doing for 3, 7, 9, 10, all of those ones. You might run into some fractions. Don't get intimidated by it. Remember to ask your neighbors for help, and if your neighbors can't help you, ask me for help. Okay, 18 and 19 both are the same type of problem. You're going to be looking at the work that they've done. So I'm going to be looking at the work that this person has done and determining what they did wrong and how I should properly graph this, or how I should properly graph this and what the proper inequality looks like. So let's take a look at this. So which describes the error in solving the inequality or graphing the solution of the inequality. So my original inequality is x minus 7 is greater than negative 2. So because this is minus 7, I would do the opposite. I would add 7 to both sides, which is what they've done, so that's good so far. And then adding 7 to both sides is going to leave me with just the x on the left side, because minus 7 and plus 7 are opposites, so they'll cancel out. And then negative 2 plus 7 is not 9. So it looks like that's where they went wrong, because negative 2 plus 7 would actually leave me with a positive 5. So this shouldn't be 9, this should be 5. Which means that this graph is also going to look different because it's not, the open circle isn't going to be at 9, it's going to be all the way down somewhere here at 5. And so now that's what I need to write into here. I need to choose the option that shows that. Let's see. The circle should have been closed. Nope, circle should be open. The wrong side of the number line is shaded. The right side is shaded, that's fine. The 7 should have been subtracted rather than added. No, we are adding then. but the 2 should have been subtracted rather than added. The 2 should have been sorry, I'm taking a pause because I'm thinking about the way they have it written is a little bit different from the way I just said it. So we added 7 to -2, which means that because those are different signs, remember with different signs we subtract, so the 2 should have been subtracted rather than added. But in order to get 9, it means that they did 7 plus 2 to get the 9, but they should have done 7 minus 2 because they have different signs, and that would have gotten them to 5. So I would choose this last one as my answer. Sorry about that pause. And then identify and graph the correct solution. So this should be x is greater than 5. So I'm going to just drag this guy over here. And then I'm going to graph that properly. That means that because x is going to be greater than 5, I'm going to use an open circle because it can't equal 5. And then all the values greater than 5 go to the right. So this would be what my graph looks like. So you're going to be doing the same thing for number 19. See, number 20 looks like it's its own kind of problem. So a small airplane can hold 44 passengers. 15 passengers board the plane. So identify an inequality that represents the additional number of passengers P that can board the plane after, it doesn't say here, but we're assuming after the 15 passengers have already boarded the plane. So if I've got this private jet that I take everywhere, if I got this private jet, I have no idea how to draw an airplane, I just realized that. But I'm going to have 15 passengers on board already. That means that, sorry about that. I'm going to already have 15 passengers, and then whatever number of people are added, I don't know. So I can represent that as P. So 15 plus P people has to be either equal to 44, because it can hold 44 passengers, or it has to be less than 44. But it can't be greater than 44 because that would be much more passengers than the plane can hold. And so the way that I would combine these inequalities would be like so. 15 people that are already on board plus an unknown number of people has to be less than or equal to 44. So I would go ahead and shade this one in. And then it wants me to also solve the inequality. And so you guys are used to doing that. So I'll let you solve the inequality for here. Let's see. B asks, which best explains whether or not 30 more passengers can board the plane? You guys should be able to reason through that. I'll go ahead and leave that one for you as well. I'm going to run out of space here on the amount of time that I can record this. So I'm going to go ahead and close this video out